Welcome students, welcome to our channel. So we have been discussing problems related to chapter work energy power. The problems have been taken from the conscience physics book class 10 ICSC. Okay, so we are discussing some problems related to work energy power. So let us continue with those problems. We will be discussing another two set of problems. Okay, so what does the first problem says that? Okay, just a minute. So we will be doing first solution number 1. Okay, so what does the first problem says? It says that two bodies of equal masses are placed at height of h and 2h. Find the ratio of their gravitational potential energy. So first of all, we will be seeing what is the formula for the gravitational potential energy. I think you know that gravitational potential energy is given by the formula. Do you know? I think you can guess. Potential energy, it is denoted by the letter U. It is given by the formula mgh, where m is the mass of the body, g is the acceleration due to gravity, and h is the height of the body above the ground. Now one thing to note here is that you cannot actually determine the absolute value of potential energy of a body. When we are using this formula, we are just calculating the increase or decrease in potential energy. When you take up a body from a certain height to a greater height, then the potential energy increases, and when you move the body from a higher place to a lower place, that is of a lower height, the potential energy decreases. Okay, so in this way we can actually say that this formula does not actually give the absolute value of potential energy. Rather, if we consider the potential energy at the reference point to be 0, then this can be regarded as the potential energy of the body. Okay, fine. Now see, so if this is the formula, so according to the informations given in the problem, we have both the bodies have the same masses. So I can say that mass m1 is equal to mass m2 is equal to, I can write, mass m, and the corresponding height h1 is given as h and the corresponding height is given by h2 equals to 2 into h, isn't it? 2 into h. So from this information, can I determine the potential energy of the first body? Yes, definitely yes. So u1 will be equal to m1, g is same as both the bodies are at same place, h1, whereas potential energy u2 can be given by the formula mass m2, g, and height h2. Okay, isn't it? Fine. Now here, then if I take the ratio, then u1 by u2 will be equal to m1 g h1 by m2 g h2. Okay, so if I just see that g cancels out, putting the value of mass m1 and m as both m, height h1 is h, mass m2 m into height is 2h. Okay, so mm cancels out, hh cancel out, so it turns out to be 1 by 2. So the ratio of the potential energy for the two bodies is given by u1 is to u2 is equal to 1 is to 2. Okay, so this is your solution, and the answer is 1 is to 2. Okay, so I think it is clear. So it was question has been asked, two bodies of equal masses are placed at height h and 2h, ratio of the potential energy. So the ratio of the potential energy is given by the ratio is given as 1 is to 2. Okay, so the solution is clear. The problems are easy, but you must follow the proper guidelines so that you can actually score better marks. Okay, now coming to the second solution. So solution number 2, solution number 2. Okay. So what is the second problem? Okay, let us see. Two bodies having masses in the ratio 5 is to 1 and kinetic energy in the ratio 125 is to 9. Calculate the ratio of the velocities. Fine. So first of all, let me just write what is the formula for the kinetic energy. I know all of you know the formula for the kinetic energy, isn't it? So kinetic energy is given by the formula. It is denoted by the as Ke. Okay, is equal to half into m into v square, means velocity square. Okay, fine. Now, in the given problem, what are the informations given? See, just let us write the given informations. Right. Okay, it has been said that the ratio of the masses of the body are 5:1. So if I consider the masses of the two bodies as m1 and m2, then definitely the ratio m1 is to m2 will be equal to 5:1, isn't it? 5:1. Fine. So that this information has been given, masses 5:1. Okay, and the kinetic energy are in the ratio 125:9. Kinetic energy, so I can write as Ke1 is to Ke2 is equal to 125 is to 9. Okay, 125 is to 9. Fine. So these are the kinetic energy, ratio of the kinetic energy. Now, so it has been asked that what will be the ratio of the velocities. So if I just consider the velocities of the two bodies to be v1 and v2, so let us consider the velocities. Let velocities of the two bodies be v1 and v2. Okay, fine. So can I write, if I say that Ke1, definitely I can write Ke1 is half m1 v1 square, whereas the value of Ke2 is equal to half m2 v2 square. Okay, fine, isn't it? So if I consider that the ratio of Ke1 and Ke2, Ke1 by Ke2, if I consider this ratio, so it will be half m1 v1 square by half m2 v2 square, isn't it? So the half cancels out, putting the value of m1 is to m2. So here it is given that m1 is to m1 is to m2 is 5:1. So I can easily write here 5/1 into v1 by v2 whole square. I can write it like this, isn't it? And also the ratio of the kinetic energy has been given. What is the ratio of the kinetic energies? 125:9. So we can write or this implies that 125 by 9 is equals to 5/1 v1 by v2 whole square. Okay, v1 by v2 whole square. Okay, fine. So from here I can write this implies that v1 by v2 whole square is equal to 125 by 9 into 5. This goes out 25, so it's 25 by 9, isn't it? Now then v1 is to v2. So what will be the ratio of the v1 is to v2? It will be if I take the square root, so I can write, if I take the square root I can write v1 by v2 is equals to 5/3. So I think the ratio of the velocities is 5:3. Therefore I can write definitely v1 is to v2 is equals to 5:3. Okay, so the solution is clear to all of you. Okay, so today we'll be ending our class here. Let us continue with the problems, numerical problems. We'll be very soon uploading another video in which we'll be discussing more problems like this. Till then, study well. Goodbye.